Welcome to the second part of the Etabs tutorial. In this part, we'll be designing a concrete building. This example project is a 6-story building. It'll have 12 feet high floors. The lateral force resisting system consists of perimeter concrete moment frames with interior shear walls. The beams are 24 inches wide by 30 inches deep. The building will also be loaded with an additional dead load of 25 pounds per square foot for partitions and equipment, along with a live load of 80 pounds per square foot for both the floors and roof. Lateral loading will be wind loads based on the ASCE 7-10 code. In this window, you can set model units, steel section database, steel code and concrete design code. Make sure to do your research on the suitable code for your design region. For this example, I'll be using the built-in settings with the displayed options. In this new model quick template, we can specify the number of stories, grid information and structural objects. It is recommended that you start your models using templates whenever possible. I'll use the flat slab with perimeter beams option. I'll set the drop panel size to be 6 feet. Ensure that the section shape is rectangular. Change the property name to concrete column and set the section dimension to the required size. You can adjust these properties if needed. In this form, we will define the beam properties. Verify that Slab 1 is selected from the slab drop-down list in the Structural System Properties area. Slab 1 is a default 8 inches thick slab section. Ensure that Drop 1 is selected from the drop-down list. Drop 1 is a default 15 in thick slab property. In the load area of the Structural Geometry and Properties form, type 25 inches in the dead load edit box and 80 inches in the live load edit box. Verify that the rigid option is selected in the floor diaphragm rigidity area. This option removes in-plane diaphragm deformations. The flat slab with perimeter beams button should be highlighted with a dark blue border. Click the OK button on the New Model Quick Templates to display the model. Make sure that the plan view is active. Change the one-story option to all stories. Click the rectangular floor tool. Change the object property to opening in the drop-down list. Ensure that the snap to grid intersection and point command is active. This will assist in accurately drawing the shell object. This command is active when its associated button is depressed. In the plan view, click once at column C3, and while holding down the left mouse button, drag the cursor to column D2. Release the mouse button to draw a rectangular opening. Hold down the Control key on your keyboard and left-click once in the plan view on column C3. A selection list pops up because multiple objects exist at the location that was clicked. The selection list will only appear when the Control key is used with the left click. Select the column from the list by clicking on it and then on the OK button. The column at C3 is now selected, as indicated by the dashed lines in the 3D view. It is selected over its entire height because the All Stories feature is active. Note that the status bar in the bottom left-hand corner of the main Etabs window indicates that 6 frames have been selected. Repeat this selection process for D3, D2, and C2. Delete the selected columns because no columns should exist at these 4 locations. Using the Wall Stacks command, we'll be drawing a wall stack in the void floors. Make sure the angle is at 90 degrees. The static loads used in this example are wind, dead and live loads. If the Model Explorer isn't displayed for you, use the Options menu to activate it. Note that the dead and live load patterns are already defined. Let's go ahead and define the wind load. Ensure that the exposure from extensive rigid diaphragms is selected. This means that the program will automatically calculate all the wind load cases as prescribed in the ASCE 710 code. You can view the different wind cases too. Verify that linear static is selected in the load case type drop-down list. Verify that wind is shown as the load pattern in the loads applied area. Select the Use Preset P Delta Settings option in the P Delta, Nonlinear Stiffness area. On the Preset P Delta Options form, select the Non-Iterative, Based on Mass option in the Automation Method area. This will add P Delta effects to the analysis. Having this message indicates that the model has no connectivity issues. Clicking the Run Analysis will cause the program to create the analysis model from your object-based input. After the analysis has been completed, the program will automatically display a deformed shape in the 3D window. You can use this form to display the wind load deformation of the building model. Each of the deformed shapes due to the 12 different wind load permutations, as specified by the ASCE 710 code, may be viewed by clicking on the VCR buttons. Verify that the design code drop-down list is set to the appropriate design code and review the design parameters as well. When the design is complete, the longitudinal reinforcing is displayed on the model. This form shows the required reinforcing steel calculated for each design combination at different locations along the length of the beam. The largest reinforcing value, either top or bottom steel, is highlighted. This report shows detailed design information about the beam. This message indicates that the shape and reinforcing of all concrete frame members are adequate. In this step, we'll be designing the shear walls. Review the design parameters shown on this form and then click the OK button to accept any changes made. The program designs the shear walls, specifying the required reinforcing based on the shape and size of the members defined earlier. A table summarizing the design of the shear wall piers will now appear in a window as shown in this video. Now you have completed the introductory tutorial for Etabs. If you did find this video helpful, don't forget to like this video, subscribe to this channel and turn on the notification to get notified on future uploads.